Hi everybody. I thought I'll make a little video to explain to you how to solve these problems on superposition patterns. So I'll just read through this first question over here, this one there. So the diagram shows wave crests being reflected from a rock face. So the bold line is the rock face. Because the reflected wave travels back through the incident wave, the height of the waves will be affected by both. For each of the positions marked, state whether the waves will have a large amplitude or whether the waves will be relatively undisturbed. So I've drawn a diagram over here and I've kind of color coded it. So this is what I've drawn for you. So that's your rock face. The blue lines are all the waves going that way. So that's the direction in which the wave is traveling. And the red ones are going in a different direction that way. So the arrow there shows the direction of the red waves. Okay, so position is, and these, the blue lines and the red lines represents the wave crests of the waves, and in between the two crests you will have a trough. Okay, so that's what we have to keep in mind. So position A is where a crest of one wave, of the blue wave, interferes with the crest of the other wave. So this is constructive interference. So the wave over here will be large amplitude. Okay. So remember, so B is where you have the crest of the blue wave interfering with the trough of the red wave. So this is where a crest and a trough interferes. So they're going to cancel each other. So it's going to be undisturbed. Okay. If you look at C, it's kind of middle. It's not on a blue line or on a red line. So this is where the trough of the red line meets with the trough of the blue waves. So this is where two troughs interfere. So it's going to be a really deep low wave. So this is going to be waves of a high amplitude. Remember, the amplitude can go up or it can go down because you have the crest and you have the trough, okay, of the wave. So A and C are high amplitude. D is where the crest of one wave interferes with the trough of the other. So that's going to be undisturbed. Okay, so that's how you solve that one. Now let's look at question 2. So I'll just take that off to get the next one. I've color coded it for you, but let's just look at the question here. So the diagram shows two wave generators, 1 and 2. They create two straight waves which pass through each other. The solid lines represents the crest. The dotted lines represents the troughs. State whether positions A, B, and C are nodal or antinodal positions. And then, so let's do that first and then we'll come back to the next part, okay? So if you look over here, so the bold lines are the crests and now they've got the dotted lines are the troughs. So let's look at A. A is where a crest interferes with the trough. So that's a bold blue line interfering with the dotted red line. So that's an area of destructive interference. So that's going to be a nodal line. Okay. If you look at B, you got two sets of dotted lines interfering with each other. So this is where a trough interferes with a trough, constructive interference. Okay. C is where a crest interferes with a crest. So that's going to be constructive as well. So you got two constructive interferences and one destructive interference. Okay, so that's the first. So constructive interference is areas of antinodal lines. So B and C are antinodal lines, whereas A is what we call a nodal line. Okay, nodal line for destructive interference. Let's look at the next part of this question. B, what is the distance in the number of wavelengths of A from each generator? Okay, right. So a wavelength is from one crest to the other or from one trough to the other. So this is A. Okay, so from here to here is one wavelength, and then from there to there is half. So you got A is 1.5 wavelengths from generator 1, so that's the red ones, and A is 2 wavelengths from generator 2. Okay, so 1.5 from 1 and 2 wavelengths from 2. The difference in distance traveled by the wave from each of the generator is called path difference. So the path difference of A is 2 minus 1.5, which is half a wavelength. So whenever the path difference is half a wavelength, it's always destructive interference, and that is what generates a nodal line. Okay? So, and then let's read the next part of the question here. When two waves pass through each other, the path difference at a point is the difference each wave has to travel from its generator. Now state in terms of number of wavelengths the path difference at each of the points A, B, and C. So we've just done for A. So how do you figure out B? So B is 1.5 from this generator, and B is 1.5 from the other generator. So 1.5 minus 1.5 is 0. So when the path difference is 0 wavelengths, it's always on the central antinodal line, and it will be an antinode. Okay, let's look at path difference for C. All right, so C's got 2 wavelengths from generator, and then 2, 3 wavelengths from the other one. Okay, so you can see 3 of the blue waves have to reach C, whereas 2 of the red waves reach C at that time. So the path difference is 3 minus 2, 1 wavelength. Okay, so that whenever the path difference is a whole number of wavelengths, you always get an antinodal line, and that's an area of constructive interference. So I hope this made some sense and you've understood that. All right then, bye for now.